Congratulations, and thank you for purchasing a legacy ornamental mill. You will soon discover that your mill is limited only by your imagination. Scary thought, isn't it? In this video, we will teach you the basic theory and operation of your ornamental mill so that you can get started right away. Now, let's stop wasting time being pleasant and get down to business. To begin with, you will want to use a dry lubricant to lubricate the rails on your machine. We highly recommend a product called Dynaglide. If you don't have some type of dry lubricant, give us a call and we'll get you set up. This product you simply spray it onto the rails and then let it dry. Apply it to both the X and the Y axis rails and let it dry. Once it's dry, the carrier should move easily but still be fairly tight. To get started, you'll need 3 turning blanks, 12 inches long, 1.5 inches square. You'll notice that I've also cut the corners off on a table saw. At this end, we've drilled a pilot hole for the center on the tailstock. At this end, with 2 screws, we've mounted the index hub. These blanks are now ready to put into the machine. Next, we'll need to adjust the tailstock for the proper position to insert the stock. Use the Allen wrench and loosen the 2 locking screws inside the tailstock so that it will slide into position. Now you can take the blank, insert it into the machine, and just slide that up until it's supporting the stock between centers. This handle now can be open or closed. You want it set at no more than a 30-degree angle here in order to lock that in place. If you open it up farther than that, you'll overload the headstock as you close the clamp to secure it in place. The first thing that we're going to do is to mill this stock round. So we'll set up the headstock here. We'll actually take the gears off and we'll show you a technique with no gears at all in milling it round. For this technique, we'll completely remove the gears here. So you just take off the black knob and the index gear will come right off the spindle shaft. Now I'll also take off the duplex gear just to get it out of the way. And we'll put on the spindle shaft handle directly onto the spindle shaft. Now we can rotate the stock directly. Now we want to adjust the bed level at each end. To do that, we simply loosen the cap screws on both the front and the back. For this diameter stock, we want to set it to the 5th hole, starting at the top here, hole number 1, 2, 3, 4, 5. When this hole opens up, we'll be at the right location. Now simply lock the screws on both the front and the back side. For milling the stock round, we'll use Magnate's bit number 2704. It's a bottom cleaning or surface planing bit. Now we will position the router bit for the cut. The router can move in the y-axis back and forth. At 0, it will be centered. However, for rounding the stock, we do not want the bit centered. We'll lock it onto the lead screw here and bring it to 0, and then we will back it off 2 turns to the back side or 1/2 inch. We can also set a stop here so that anytime we bring it into that stop, we know we are offset 1/2 inch from center. We will set a stop, however, at 2 inches from the end on the x-axis. So simply slide the carrier tray into place and then lock the shaft collar in place. To set the plunge depth, we'll simply turn the stock till there is a flat surface up. And then we will plunge the router down till the bit is resting onto the stock. Now the milling procedure will be as follows. We have our plunge depth set, we have our y-axis and our x-axis set. So we'll simply plunge down, turn the router on and bring it over center, but it's offset 1/2 inch. And then as we rotate the handle counterclockwise, we will slide the carrier tray along manually. First we'll need power to the router. All right, now we have our router plugged in, we're really ready to go. Now we start by making a test cut just to see if we've left any of the surface as we rotate this. Here we have just a little bit left on this side, so we'll readjust our plunge depth for just a few thousandths, maybe 10, 20 thousandths of an inch, and cut it again. Okay, we're removing all of the surface now, completely around, so we're ready to continue the cut. Okay, there's one step, is by simply rotating it and moving it by hand. The other way that you can do it is to actually rotate both these handles at the same time. I'll show you that. It's a little tricky. Now as you rotate these two handles, this handle will rotate the stock. This one will feed the router along with the lead screw. So this time we will lock it onto the X-axis lead screw as we're making our cut. Now you can see we have milled around. Both techniques will mill it extremely smooth. However, the first one will give you a slightly better finish. Next, we're going to mill this part on a taper. To do so, we'll need to adjust the bed. You'll need to loosen the cap screws on both the front side and the back side. Do this at the tailstock end, and then simply raise this. On this particular part, we'll raise it all the way to the top and lock it down, both front and back. All right, now we're going to slide the carrier tray along the X-axis to 4 inches. And here we'll set a stop so that we won't cut all the way up to the beginning position. If you remember, we started at 2 inches. The tapered section now is going to start at 4 inches from the end. Now with the bed set at a taper, this end raised up, and the stop and the X-axis set at 4 inches instead of 2 inches, we're ready to cut our taper section. The only thing that we'll need to do now is to reset our plunge depth. We'll simply plunge the bit down until it rests on the stock at 4 inches, and that's the depth that we'll use. Now you can see that the stock has a straight section for the first couple of inches to 4 inches from the end, and from there it tapers down to the very end. Next we'll set up and we'll cut some flutes in here, and then we'll come back and cut some joinery at the end to show you the indexing system. For milling the flutes, we'll use the indexing that's built right into the indexing gear. So we'll replace the handle with that gear. Now this gear has 24 positions on it, so anything divisible by 24 can be milled on here. We'll cut 8 flutes on this section, which means we'll go every 3rd hole. The indexing head is pretty straightforward. The pin can be held back with this locking plate. To release it, just press on the plate and the pin will slide forward. It's spring loaded and it'll lock into any one of those holes on your index gear. To begin with, it doesn't matter where we start, but we'll go every 3rd hole once we start cutting flutes. For the fluting, we will use Magnate's bit number 805. If you haven't seen this chuck before, it's because it's built specifically for the Porter cable routers. It's called the Eliminator chuck. It makes changing your router bits very fast and easy. If you have a Porter cable and want one of these chucks, just contact us and we'll set you up. The next thing we'll want to do is to set the Y-axis stop so that instead of being a 1/2 inch off center, we'll be right at 0 or centered on the turning blank. Lock that cap screw there. I'm also going to set the x-axis stop so that instead of being at 4 inches, it's going to be at 4.5, and that will be our starting position. And at 11.5 inches, we will set the other stop, so our flutes will be that long. These are going to be blind stop flutes. Next, we'll simply set the plunge depth by dropping the bit down until it just sets on the stock. Once it touches the wood, we can set the plunge bar for any height we want. I'm going to plunge down approximately 1/8 of an inch and lock that in place. Now with our indexing set, our router centered, and our stop set, we're ready to start cutting flutes. Now you can see that the flutes are evenly spaced, and we have 8 of them because we used every 3rd hole on a 24-position indexing plate. Also notice that the bed is the same level, so the flutes are the same depth, the full length of the stock. If you adjust one end higher or lower, the flutes will be teardropped. With the flutes cut, we're going to set the bed back to level by setting this end back to the 5th hole on both sides. And then we'll come back and set our stops. We will mill a flat in this first couple inches at 90 degrees, and then we'll cut mortises in here for our rails to come into. All right, loosen the cap screw on both the front and the back side, and again adjust the machine until it's back to the 5th hole, 1, 2, 3, 4, 5, and lock it in place again. We'll need to do a couple of things. First, we'll move the lead screw so that the router can move all the way back and forth across the stock. Then we'll set the first stop at 2 inches. Then move the carrier down 1 inch to 3 inches and set the second stop at this position. Now I've changed the router bit back to the 2704, the surface planing bit, so that we can mill a flat surface. We'll just plunge it down till it rests on the stock like before, and then adjust our plunge depth here for approximately 1/8 of an inch. Now we'll index the 6 holes, which will be 90 degrees, and then repeat the same operation. For milling the mortises, we'll use a 1/4 inch spiral upcut. You could use a 3/8 or 1/2 inch or whatever size you want for the mortise. In this case, we'll use the 1/4 inch, which required a collet adapter for the eliminator chuck. Now we'll index at 6 holes, just as we did the flats, and put that into position, and we're ready to cut the next mortise. Okay, here you can see the finished parts. We have a straight section with flats at 90 degrees for the rails and the mortises, and then the tapered section with the evenly spaced flutes. Well, all right, so far so good. We've learned how to mill the stock round, how to set the bed for tapering or straight cuts. We've also learned about the indexing system. Now we're going to cover the spiral drive and the gearing. We'll start here by defining one simple term, is what we call pitch. When you hear pitch, you'll think about how far the router is traveling along the length of the stock for every rotation of the stock. So we'll define it as such. The distance divided by each rotation. Now, as we look at some parts and start using the system here in a second, you'll soon find out what that means. But just keep in mind, pitch equals the distance the router travels for every rotation of the stock. Now, there's a simple formula that we use once we have defined pitch to decide how to set the pitch on the machine. We'll let P equal pitch. So to calculate the pitch, we'll use the diameter of the router bit, whatever the router bit diameter is, times the number of starts. Again, this will mean more as we get into this and you'll see it operate on the machine. But let's just use this formula right here and plug in a couple of numbers, and then we'll show you how to set that up on the machine. Let's say, for example, that we're using a router bit that is 2 inches in diameter. And let's say that we're going to do 3 starts. So in this case, 2 times 3 would give us a pitch of 6 inches. We would simply set the gearing for a 6-inch pitch. Let's plug another number in here. Let's say that we have an 1.5 inch cutter, and we're going to do 2 starts. Then our pitch would equal 3 inches. All right, now let's take a careful look at the gearing system here and decide how we're going to use this. Let me explain this real quickly. There are 3 parts to the gear system. The first is these 2 large gears working together. We call this the gear reduction. The last gear here at the end is the drive gear, and that will determine your pitch. The center gear here will determine the direction of the spiral. You can think of this as a 21-speed bike, and that'll help. If this represents the front sprocket of your bike and this gear represents the rear sprocket, if you change the rear sprocket, you'll change the gear. On here, you'll change the pitch. And there are 7 of these gears. So if I simply change the last gear here, we will get one of 7 different pitches. Now, this one here, if I change this mechanism, it will change the direction. In 21-speed bike, that doesn't matter, so we're a little bit different here. But that'll make it either a right-hand or a left-hand spiral. This will change one of the 7 pitches. Now, if we change the gear reduction set, we go with the 0.25 times gear reduction or the 2 times gear multiplier, then we'll get a whole different range of 7 pitches. So each gear reduction set will give you a set of 7 pitches, giving you a total of 21. On your headstock, you will find the label for the gear chart. This will tell you which gears to use for which pitch. It's a little difficult to read here, so we'll look in the manual at the chart. Now here's the chart as you'll find it in your manual. It's the same as the headstock chart. This is just a little easier to read on film, so we'll use it here. Now on your chart you'll see these rings, and they represent the diameter of each one of the drive gears. If I take any one of the drive gears and lay it on this chart, make it even at the bottom here, I can identify the drive gear. This, for example, is the C gear because it lays right on there. That's the diameter. Now, once you've identified the drive gear, this chart will tell you what pitch that'll set. If we use the C drive gear, as you find in this column here, as you look across that row, you'll see what pitches it'll set depending upon which gear reduction. Now with the standard gear reduction set, as comes with the Model 1000, you'll have this column here, and that's why it's dark, because that's the standard set. With the C gear and the standard set, you get a 4-inch pitch, meaning the router is going to travel 4 inches along the length of the stock for every rotation of the stock. Now if you change one of those drive gears, let's say you put the A gear on, you'll get a 2-inch pitch. If we put the F gear on, we would get a 6-inch pitch, and so on. will be within that range. Now if we change the gear reduction set, the C gear, instead of giving us a 4-inch pitch, you'll see it gives us a 1-inch pitch. The reason that's called the 0.25 times is because that's exactly what it does. It's 1/4 of the original value of these pitches. So 0.25 times 4 equals 1 inch. Now if you go the other way, you look at the 2 times gear multiplier, that's exactly what it does. If you take 2 times 4, you'll get a pitch of 8 inches. So by using the C gear in one of these gear reductions, we'll either get a 1-inch, 4-inch, or 8-inch pitch. We're going to make 3 different parts to illustrate how to use this formula. In these parts, we'll use the same size router bit. The router bit diameter will always be 1 inch. Okay? We will just vary the number of starts to show you how this works. On the very first part, we'll use a 1-inch diameter bit and we'll do a single start. On the second one, we'll do a 2 start, and on the third one, we'll do a 3 start. Just work this formula real quickly. It's very simple to see. On the very first part, the pitch will equal 1 inch. On the second part, it will equal 2 inches. And on the third part, it'll equal 3 inches. Again, you can plug any diameter bit in there, any number of starts, and that'll tell you the pitch. Then look at your chart on your headstock, and you're ready to go. For our first example, we determined we wanted a 1-inch pitch using a 1-inch diameter router bit and a single start. To get the 1-inch pitch, you just look in all of the columns till you find the number 1, and then I'll identify that we use the C gear and we'll use the 0.25 gear reduction set. For our second sample, we had still the 1-inch router bit, 2 starts, gives us a 2-inch pitch. So for a 2-inch pitch, we'll use the standard gear reduction set, so we'll need to change the gear reduction, and then we'll change to the A size drive gear. On the third one, we'll use a 3-inch pitch, so we'll leave on the standard gear reduction set. We'll just change the drive gear to the B size gear to give us the 3-inch pitch. Now for milling these rope spirals, we're going to use bit number 7571. It's a 1-inch diameter rope molding bit. You could also use bit number 7551, which is a 1-inch diameter barley twist bit. It doesn't really matter, both will work the same. All right, we'll start by setting up the machine. This part has already been milled like we did previously. Now we're going to set the machine, we'll set the stops for the x-axis at 2 inches and also at 6 inches. Then we'll set the router so that it's set in the y-axis at 0, so it'll be centered directly over the stock. Next we'll need to set the plunge depth. Now to do this, I'm actually going to move the router off to the side a little bit and plunge down until the shoulder of the bit is resting on top of the stock, and lock the plunge down right there. Here you can see how the shoulder of the bit is resting on the top surface, and that's the depth that we'll need to cut. Now to set the gearing. We're going to use the C-size drive gear and the 0.25 gear reduction set. So the first thing to do is to put on the 0.25 gear reduction set. We'll take off the standard set. These just slide off. And we'll start by putting on the index gear and securing it in place. And then the duplex gear, which has the 2 gears that are bolted together. Now at this point, you'll want to engage these 2 gears to begin with right there. The next step is to change the drive gear. So we'll take the handle off, take off the spacer, and then the drive gear. We'll replace it with the C-size gear for the 1-inch pitch, and then we'll replace the spacer and the handle. And finally, we'll engage the gears up to the drive gear. Now these gears can all shift back and forth and float. They're built that way so that you can mill tapers as well on spirals. So once you get it engaged, you'll then want to just turn the handle and make sure all the gears are fully engaged and rotating. If they slip at this point, you simply re-engage them in both directions, and then they'll lock in fully and be ready to start cutting. All right, we're ready to cut our spiral. We're going to start by cutting just around the circumference with a half bead to begin with. So we'll leave the split nut open. The threads will not be engaged into the drive screw. The plunge depth is set. We'll just bring it over center and rotate the stock one full rotation. Now here you can see we've milled completely around the stock using the rope molding bit to cut that half bead. Now from this position we'll start our spirals. This time as we're making our cut, we're going to close the split nut down onto the lead screw. Make sure it's fully engaged and brought back to the starting point. Now when we bring it over center and turn the handle, it'll cut down to the 6-inch mark. Now at this point, if we want to cut a bead around the end, we'll simply open the split nut and cut around this end. Now here you can see the bead, or the half bead we cut at the start and at the end, and the single start spiral. If you look at this and you measured the distance between those cuts, it's exactly 1 inch, and that was controlled by the gearing. No matter how fast or slow you turn the handle, it'll feed it exactly 1 inch because of the gear set. This is called a single start spiral. Now we'll change the gearing to a 2-inch pitch. We decided we needed the A drive gear, which is the largest of the drive gears, and we'll need the standard gear reduction set. So we'll begin by replacing the gear reduction. Once the gear reduction is in place, go ahead and engage those gears, lock them in place. Now we'll change the drive gear. Now with that in place, we'll engage these gears, bring them into place, and then again just test it to make sure they're fully engaged and ready to go. The plunge depth, the y-axis, is all exactly the same. We have moved our z-axis to start at 7 and end at 11. So now we can just cut a ring around the beginning and start the spiral. Next, we'll close the split nut onto the lead screw, bring it up to the starting position, and make our spiral cut. Here you can see the spiral that we've just cut. Now the cutter is 1 inch in diameter, as you can see here. The pitch is 2 inches, so it left a 1 inch spacing in between. So all we need to do now is to bring the router bit right in between these two cuts and mill the second start, and it'll finish off a 2-start rope. The first start of the spiral ended at 11 inches. We can see that on the scale here on the carrier tray. So what we need to do is lift the router bit out of the cut, simply open the split nut, and then slide it 1 inch, or the diameter of the router bit, and lock that back onto the lead screw. That will set it so that it's in between the last two cuts. Once again, if we ended at exactly 11 inches on that last cut, on the very first pass, we'll then simply open our split nut, raise the bit out of the stock, and slide it back 1 inch, or exactly the diameter of the bit. We lock it back onto the lead screw, and then crank it back to the starting position. We always want to cut one direction, from the headstock towards the tailstock, or the opposite, it doesn't matter which, but it should always be the same direction. Here you can see the 2-start spiral. The second pass we just cut here, and the first pass we cut here. The spacing between each cut is 1 inch. The pitch set by the gearing was 2 inches. For the last part, we're going to do a 3-inch pitch. So here all we need to do is change the drive gear. This is for the 2-inch pitch. The B size gear will give us a 3-inch pitch with the standard gear reduction set. And finally engage the gears and test that they're fully engaged as they run. For the 3-start spiral, I want to show one other thing here. You'll notice that this blank has not been rounded. We have cut the corners off on a table saw to remove most of the stock, but you can cut the spirals directly into the blank without rounding it first. The gearing is set for the 3-inch pitch. The plunge depth is exactly the same. The y-axis is already set, so all we need to do is set our x-axis where we want to begin and end this cut. We'll start at 2 inches and we'll finish, I'll say, at 6 inches. Now one thing that I like to do is to engage the split nut and turn it till it's on an even number. And at that point, that's where I'll set my stops, make sure the handle is straight down. Every turn of this handle is 1/4 of an inch. So if I do it that way, then my stops will be when they end straight down. I'll know exactly when I'm at a single digit, like 1 inch, 2 inches, 3 inches, and 4 inches, and so on. So we'll put the handle straight down and adjust our stops to match exactly. Now we'll begin the cut by opening the split nut and cutting around the circumference. First thing you notice is that this makes more sawdust. It kicks off because we didn't round it first. So it doesn't matter if you choose to round it or not, but this will put more wear and tear on this particular router bit. You can see we've cut all the way around. If one of these surfaces was not deep enough, we would adjust our plunge depth accordingly, but this one looks good. It's ready to go. Now we'll close the split nut bring it up to the starting position, and make our first pass. Now at this point, we do the exact same thing. Simply open the split nut, slide it back 1 inch, and lock it onto the lead screw. And it's positioned ready to cut our next pass as soon as we wind it back up to the beginning position. The second pass will do the exact same thing. But let me show you one little thing right here that you'll want to note. Let's say that you're milling a real long piece and you get way down here at the end. Now, if you open the split nut, move it back 1 inch, and close it, you can see I've got to now crank it back here, 30 inches. That's a lot of cranking. You can avoid that as well by using the split nut. And it doesn't matter where the stock is, as long as the bit is centered. You open the split nut, you can now just slide it back down to the beginning position. Now once you've done that, you've lost your synchronization, so you must synchronize the bit with this cut that you've just made. If you slide that bit along, at some point the bit will plunge right into the same groove. Once it does, if you lock the split nut, you're again milling in that exact same spiral that you were just in. From that point, you can then open it and move it 1 inch and lock it in place. Now I only have to back it up the last couple of inches instead of cranking it all the way from down here at the end. If you do that, remember to synchronize first, and offset the diameter of the bit, in this case 1 inch, and then crank back to the beginning position. And then your spirals will come out just right. As we zoom in here, you can see we have made 2 passes. If we were to trace this cut here all the way around and measure that, it would be 3 inches. That again is set by the gearing or the pitch. We then moved it 1 inch to cut our second pass. So we've cut 2 of the 3, that's a 1 inch spacing. You'll notice there's a 1 inch gap in between. So we'll take the bit, move it back 1 inch again, set it right in that position, and begin the cut to finish our 3-start spiral. So I'll bring the router bit and I'll plunge the bit right into the last groove that I cut, and then we'll make the 1 inch offset, and then we'll crank back to the beginning. There's my last cut. Lift it out of the cut, move it 1 inch, lock it down, and bring it back to the starting point. Now the reason I don't plunge here at the beginning to make my cut, I crank it off to the side to start it, is if you plunge directly on and let it sit there, you can burn the wood or you can create a little divot. So by bringing it from the side over, it eliminates that problem. Now I'm going to open the split nut right here and I'm going to cut around the circumference. The next thing I'm going to do is I'm going to move the router down 1 inch and make a second cut. Now if I leave the split nut engaged, then by simply cranking the handle, it'll move it exactly 1 inch. Notice the handle is straight down. I set it up that way intentionally. I go 1 turn, that's 1/4 of an inch. 2, 3, 4 turns is 1 inch. Now I'll set that stop at that position, open the split nut, and make the second cut. Okay, here's the 3-start spiral. The spacing between each cut is 1 inch. The total pitch is 3 inches. And here we've moved the bit down exactly 1 inch to cut this bead. You can move it any distance that you want, but in order to form a full bead with a point cutting roundover or rope molding bit or some other bit like that, you move it the diameter of the bit. Next, we're going to mill some flat stock. So instead of working between centers like we did on the last section, we'll be working on the flat bed. Now when you assembled your machine, there was some hardware locking plates that went inside the bed rails, the inside 2 rails. What you need to do is cut a board, and I use 3/4 inch MDF because it's nice and stable and flat. Cut it exactly the width of the inside rail so it fits inside the 2 outside. Then we'll take some hardware and just mount it to the rails here. Now the hardware that comes with the machine are actually flat heads. I'm using cap screws instead. They extend up here and get in the way, but I can use my Allen wrenches to set them. You don't have to go to a screwdriver. It doesn't matter what type of hardware you use, you just need to mount the table. Now once the table's on there, you'll notice that we can move it. I have put a 1/2 inch spiral upcut router bit in here. What I will do is I will lock the carrier onto a position, and I'm going to set it at 30 inches in this case. I'll also set the router at 0 or centered here, and then I'll plunge the bit into this hole. Now I show you how to make this hole to begin with, but once that's in place, that table is in the position I want, I will then lock the table down. Now to make this table, all I did was simply set the table where I wanted it, positioned on the stock, and of course it can be the full length of the machine. I'm just using a short section here to show you a demonstration. But once the table's on and positioned where you want it, then for the rotary table, what you'll do is put the 1/2 inch spiral up cut in, position the router wherever you want it, pick an even number like 30 inches or 25 or whatever you desire, set it at 0, and then just plunge down in and cut that hole. Now this bed is set in place. We're ready to mill on this flat table. All right, now what we need to do is adjust the bed. We'll need to lower this bed to give us clearance for the stock. We'll simply loosen the cap screw on both the front and the back, and then lower the bed down. Now we're going to go to the 6th hole on the one side, or the 11th total hole from the top. If we start here at the top hole, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or we can simply go 1, 2, 3, 4, 5, 6, and that is the hole we want to end up at. When that hole is open and lined up, we'll go ahead and lock these in place. Make sure you set all 4 legs to the exact same position. Now this blank has been cut 12 inches long, 3 inches wide. It's just 4/4 stock. We're going to use this as a sample. We'll plane it, and then we'll cut some parallel flutes in it to show you how to use the XYZ milling table. We'll start by attaching the stock to the table. Easiest way to do this, there are several ways, but the easiest way is just use double-sided tape. Now if you put too much tape down, you'll never get the part off the board. So we'll just put a piece at each end, like so. Peel the backing off, and this board is now ready to attach to the table. The question is, exactly where do we put it on the table? You look on the table, you see a line that's been scribed on here, drawn. And the way that I did that line was that I took and put a V groove bit in the router. Once I had the V groove bit in there, knowing that this stock was 3 inches wide, if I'm at 0, I want to be at the center of the stock. So I moved the router off 1.5 inches to the near side. Put that V groove bit in there, plunged down, and just ran it along the table, and that scribed a line in here. And I took a pencil and made it darker so that I could see it. Now we'll take the stock. I've already pulled the backing off the tape, and I'll just align it with that line. Now once I have that in place, if I want to go to the center of that stock, I just go to 0. If I want to go to the edge, I go off 1.5 inches. Now I'm going to show you a technique how to plane stock. We'll simply take the router bit. This is a surface planing bit that I have in here, the 2704 again. I'm going to drop down till it touches the surface, and then I'm going to raise my plunge bar, just a little bit, 1/16 of an inch or less. And I'm just going to make multiple passes across here, kind of like mowing the lawn. Here's how it works. Now that planes it extremely smooth. You'll notice that for each pass I was turning exactly one turn of the handle. That moves it 1/4 of an inch. If you're cutting a real light pass, you can move it as far as 1/2 inch. The deeper passes you want to move it less. The advantage of planing your stock this way is a couple of things. Number one, if you have a highly figured wood or a burl or something like that that you would put through your planer, it would tear the grain all out. But by milling it flat, you can do any types of wood. The other advantage is that if I were to put a straight edge on here now, you will see that it has removed any twist or bow or anything. The surface is perfectly flat. Now I'm going to cut blind stop flutes, meaning they're going to stop here at the end. They're not going to bleed off. So we'll need to set a stop on the x-axis. We'll set a stop here at 1 inch from this end, and also, let's say 1 inch from the opposite end. Now those stops are in place. I'll need to set the plunge depth. I'll just plunge the bit down till it sets on the stock, and then set the plunge bar for approximately 1/8 of an inch. Now I'm going to cut these flutes so there'll be 1 inch spacing. If we put it at 0, of course, we're cutting right down the center. So if I move the handle 4 turns, it will move over to the y-axis to the 1 inch off the back side. That's where I'll cut my first flute. We do these flutes the same way. We'll plunge down, slide it to the end, and then bring it out. Always cutting in the same direction. After cutting our first flute, we'll simply turn this handle 4 turns. 1, 2, 3, 4. That'll put it at 0, which again is centered in the stock. Now you can see we've cut our 3 evenly spaced flutes 1 inch apart, and they end 1 inch from the end of the stock. You can control the router in both the X and the Y and the Z axis to create all types of dental moldings and other designs. We'll get more into that later. All right, now we'll peel this part off. Takes a little bit of pressure. Take the tape. The next thing we're going to do is we're going to work on a rotary table. Now Legacy is developing a new one that'll mount on here and will be gear driven, so it'll do this automatic. But if you want to build your own, here's what you do. We've of course drilled the hole in there. This is again is a piece of 3/4 inch MDF. Now originally I cut it square and I drew some cross squares on it to find the center, drilled that, and actually mounted the stylus that's used for the template follower on the bottom to act as a pivot point. That'll fit right in that 1/2 inch diameter hole. I then cut it round in a bandsaw. I put it on here with a router bit and just turned the stock, and that machined it to a perfect round. Now once it's on there, we can take our stock. I've put some double-sided tape on here. I've also got some sawdust on there on accident. You don't want to do that. We'll use those crosshairs to align this part. If you put each corner aligned with the crosshairs, press that down, that'll mount the stock. Now we're ready to start cutting our spirals. All right, now I laid out some indexing on here, and the way I did that, I have these crosshairs on this round table. When this crosshair is parallel with this rail, and I can measure the distance there, then I know it's flat, it's straight here, and I can mark indexing positions on those corners. If I turn this 45 degrees until this square part here is flush with these rails, then I have 45-degree markings, and I laid out a mark in between those, so I have a total of 1, 2, 3, 4 per quarter, or 16 different indexing marks that we'll use to cut this. Now what we'll do is we'll simply bring the router up and locate it exactly on 30. That's centered in the stock. Now, instead of cutting all the way to center in the y-axis, I'm going to move it, instead of at 0, 1/4 of an inch, which is 1 turn, to the back side. And that's where I'll set the stop. When we create this rosette, it'll have a little point in the middle, and that's because of this offset. Next, I'll just plunge the bit down till it touches the stock, and we'll set the plunge depth for approximately 1/8 of an inch. Now, I'm actually going to open the split nut so the router will just slide in the y-axis rather. And I will hold the table in place as I make a cut, like this. Now we have made the indexed cuts on this rosette. The next thing we're going to do is we're actually going to position the router bit right at the edge and mill around the circumference. What we'll do here now is lock the y-axis screw on. Now this block is 3 inches square, so when we bring it into 1.5 inches, it'll be set at the edge of the stock. The plunge depth exactly the same. You can see we've milled the indexed cuts and also a circular cut with the same router bit, core box bit. Now we'll need to remove these corners. We'll do that with just the 2704, which is a surface planing bit, and mill it flat. Now we'll change this bit to the 2704, which is the surface planing bit, or bottom cleaning bit. Then we'll need to set the plunge depth. We'll just plunge the bit down till it's at the bottom of the cove, or the same depth. I'm actually going to raise the plunge bar just a little bit more so it'll raise it. It'll make it pop. And we can set the bit so that it's at the edge of the bit is at the edge of the blank, and lock it onto the lead screw so it can't move side to side. And we're ready to make the next pass. And there's our indexed rosette. Now you can obviously change the router bit. Try different bits. Use a rope molding bit, core box bit, V-groove bit. You can create many different designs just by varying the position, the stops, the number of flutes, and the router bit. Well, congratulations, you've completed the class. As you see, the machine is actually very simple to use once you understand the gearing and basic milling procedures. Almost